telescopes. I took information for telescopes from a few different sections in your textbook, so take a look at those page numbers if you wanted something extra beyond this lesson. We use telescopes to magnify and observe objects that are great distances away. Optical telescopes magnify light to make observations about the universe. These are the ones that we use at home, observatories, and in space. We also have radio telescopes, infrared telescopes, and other types that can work outside of the spectrum of light that humans can see. The optical telescope uses an objective lens and an ocular lens. The objective lens is the large lens on the front of the telescope, furthest from your eye. The ocular lens is the eyepiece that you view the magnified object through. So this is the one closest to your eyes. This was invented by Hans Lippershey in 1608, and it was improved by Galileo later that century. Telescopes are often attributed to Galileo, but he wasn't the one that invented them. He simply used them to start looking out at the stars. So Galileo's observations from turning a telescope from, let's say, Earth, the birds, and looking further in the distance, he turned it out to space. He observed that there were spots on the sun that moved across the surface over a period of the month and then disappeared and reappeared on the other side. He concluded that the sun must be rotating. He also saw shadows on the moon that lengthened and shortened with the sun's angle. He concluded that the moon had mountains and craters like Earth, that it wasn't a flat surface. He observed that Jupiter had 4 small stars that moved back and forth across his view. He concluded that Jupiter's moons must orbit the planet, Jupiter. He observed that some planets were disc-shaped. He could see some detail, but because the stars were still just absolute pinpoints, he couldn't see any detail. They must be further away. So based on the level of detail he could see, he could identify which objects were closer and which ones were further away. His findings contradicted the Earth-centered model that was in popular view at that point. And because he was outspoken about it, and they did not like that his observations didn't match their knowledge of the universe, he was thrown in jail. Resolving power of a telescope refers to how fine a focus can be achieved when looking at a distant object. So just like when you adjust the resolution of an image on your computer. Resolution is controlled in part by the diameter of the objective lens. Remember, that's the furthest one from your eye. A wider lens produces finer detail. However, we can only go so large with this wider lens. It can only grow to be so big. Higher resolution means a crisper and more detailed image. Optical telescopes, again, are light collectors. The series of lenses or mirrors enable the optical device to collect and focus the light from the stars. A refracting telescope is the one that was first designed. It uses 2 lenses to gather and focus starlight. The objective is a convex lens. Light refracts or bends when it passes through this lens. The telescope itself is closed. Okay, so the lenses are protected and don't need cleaning or adjustment. So the lenses are at the front and the back of our telescope. These are limited in size. We can't make a lens here greater than 1 meter in diameter. And remember, the size of this lens is what gives us better resolution. We can also only make these so long. The tube length increases with the distance you want to view the object from. So the further away something is, the larger and longer the tube needs to be. These were costly because of creating those lenses, and the image can be blurry or distorted because lenses break light into colors, making a bit of a halo around bright objects. A refracting telescope is shown here. Okay, so again, these are the ones with lenses. The objective lens gathers light and bends it into focus. Our lens, focuses the light to one point. Where that point is viewed is the focus point. The eyepiece is where you would look into to view this focus point. So Galileo's telescopic observations helped to confirm the sun-centered model. Kepler, a German mathematician, solved the problem of planetary motions. He concluded that planets orbit in an elliptical pattern versus a perfectly circular. Remember, an ellipse is like a squashed circle. He also figured out the size and the scale of the solar system. So just on their measurements alone. So you're seeing here, the sun is at one end of the elliptical orbit. It is not perfectly centered. In contrast to our refracting telescope, we have a reflecting telescope. This is designed by Isaac Newton. It used a primary or concave mirror instead of a lens and a secondary mirror. Light from a star is magnified by reflecting it using these two mirrors. Again, the objective is a mirror, not a lens. The light is collected by this big concave mirror. The mirror reflects light to a smaller flat mirror, and this secondary mirror directs the light through an eyepiece for us to see. The eyepiece has a lens, and it magnifies that last image. These are cheaper and easier to make. We can make really large mirrors for more light collection, whereas we're limited in size to how big a lens can be. Tube length doesn't increase. We just have to adjust mirror angles. These are open to air though, therefore they need to be cleaned, realigned, and the metal coating on our mirrors needs to periodically be replaced because of corrosion. Here's an image of our reflecting telescope. The light from the stars comes in, is collected in this primary mirror, which is concave. It directs the light to a secondary mirror and is focused to an eyepiece. Both a refracting and reflecting telescope are great, but the combination together can be very helpful. Refractors give better images than equal-size reflectors, but reflectors can be made much larger. So a combination or catadiatropic telescope has a lens at the front and an objective mirror at the back. So we can use both to help focus our images. There's a little video here on how do telescopes work. I've linked it on our website below. Interferometry. This is a method of combining telescopes for greater power. When working together, these telescopes can detect objects in space with better clarity and at greater distances than any Earth-based observatory. So for instance, the Very Large Array, or VLA, in New Mexico consists of 27 radio telescopes, which we'll talk about radio telescopes, but 27 telescopes arranged in a Y configuration. All of these telescopes are used simultaneously to observe something, and then their observations are all added together to make a much more clear image. Adaptive optics. One of the problems with Earth-based telescopes is that looking through the Earth's atmosphere is light pollution. So the Earth's atmosphere distorts or refracts the light from the stars. This is what makes our stars look like they're twinkling. To fix this problem, telescopes would use adaptive optics, which is a computer program to correct the image. To fix the light pollution from cities, telescopes are located in remote north or on mountain tops for the clearest images. Orbiting telescopes were launched in 1990s, like the Hubble Space Telescope, and they are placed into orbit around the Earth. From space, the images captured are clearer because they don't need to go through Earth's atmosphere. These telescopes allow astronomers to view the universe in all wavelengths of light, so not just what we see. By being able to view the stars in other galaxies, scientists have been able to determine the age of the universe and the way that galaxies form. The Hubble telescope is a reflecting telescope, meaning it has mirrors. The main mirror is 2.4 meters in diameter. And fun fact, when it was first launched, they realized the mirror wasn't in sharp focus. One measurement in the mirror system was off by 1 millimeter, and they had to do a space exploration mission just to fix the telescope to get clear images. So never say that measurements aren't that important. The Hubble Space Telescope allowed us to see the formation of new galaxies, to learn that there is an immense black hole at the center of most galaxies, and to have a better understanding of dark energy and how the universe is expanding. Complete the learning guide for this topic, and there's some extra practice in a couple different places in your textbook here for you.